To provide accurate IFR navigation, Enroute and area charts are published depicting IFR routes, radio facilities, radio frequencies, Enroute altitudes, and various other information. It's essential that you be able to extract needed information rapidly and accurately from these charts. Enroute charts are produced in two groups. The first is for use in the high altitude structure. The second is for use at lower altitudes, up to, but not including, 18,000 feet. During this program, we'll look at the information on these low altitude charts, since they will probably be the first Enroute charts you will use during your instrument training. The National Ocean Service, NOS, prints 28 low altitude charts covering the United States. An index panel on the front shows the area covered by each chart. This panel aids you in selecting the charts needed for a specific flight. Major cities are shown to further aid you in your chart selection. Cities in black depict terminal areas for which an area chart is published. The bold lines indicate the chart in hand. On the chart index, time zone boundaries are indicated by dotted lines. The standard time zones are indicated at the top of the chart. A legend describing the meanings of the symbols is printed on the inside of most charts. Each chart contains 5 colors. Brown is used to show low and medium frequency aids and route data. Airports without a published instrument approach, military training routes, and the borders to military operation areas. Brown is also used to depict areas of Class G airspace, which extend from the surface up to 14,500 feet. Within the conterminous U.S., all airspace above 14,500 feet is controlled. The white areas on the chart represent areas of Class E airspace, unless otherwise indicated. Blue is used for air defense identification zones, as well as prohibited, restricted, alert, and warning areas. In addition, blue depicts Class C airspace. Class B airspace, Air Route Traffic Control Center boundaries, as well as ARTCC remote sites. Airports shown in blue have an approved instrument approach procedure published in both the Department of Defense and the NOS flight information publications. Airports with instrument approaches, which only appear in the NOS flight information publication, are shown in green. Green also is used to depict shoreline, time zones, and isogonic lines. The majority of black print is used for VHF and UHF route data, such as VOR nav aids, communication and frequency boxes associated with the navigational facilities, and airways. VOR facilities on the chart are indicated by a hexagon symbol, normally enclosed in a compass rose, oriented to magnetic north. A TACAN facility operates in the UHF frequency band to provide azimuth and distance information for military aircraft. When a VOR and TACAN facility are co-located, the resulting facility is called a VORTAC. A VORTAC is shown on Enroute charts with the extensions of the TACAN symbol filled in. Properly equipped civil aircraft can use the VOR portion of a VORTAC for course guidance and the TACAN part for distance information. This is accomplished through frequency pairing, which means that when you select the VOR frequency, the UHF frequency of the TACAN is automatically selected by the DME equipment in your aircraft. To civilian aircraft, a VOR DME nav aid works like a VORTAC station. When you select the proper VOR frequency, your DME is automatically paired to the correct UHF frequency. The information boxes associated with nav aids provide the name of the facility, the frequency on which the nav aid transmits, the identification letters, if available, the channel number used by the military for DME, the Morse code, which corresponds to the facility's identification letters, and the geographic coordinates for that facility. Flight Service Station communications frequencies available at a nav aid are listed across the top of the information box. The letter R indicates that the facility only receives on that frequency. If it's followed by a T, it means the frequency is only used for transmissions. When the FSS has a remote antenna at the site, the name of the controlling facility is added. Shadow boxes indicate the standard Flight Service Station frequencies are available in addition to those listed above the box. FSS standard frequencies include 121.5 and 122.2. A solid square in the upper left portion of the box means that hazardous in-flight weather information is available from HIWAS. A white T in a black circle indicates that the facility has transcribed weather broadcasts. If a line appears under the frequency, the nav aid has no voice capability. An overprint on the frequency indicates some type of abnormal status, and you should check the NOTAMs. In this case, the NOTAM indicates the VOR may be shut down. VHF navigation routes, which are defined by VORs, are designated as Victor airways in the low-altitude structure. In this example, the airway running southeast of Farmington is designated Victor 178. In order to fly outbound from Farmington on this portion of the airway, you must maintain a magnetic course of 129 degrees. Victor airways are normally 8 nautical miles wide. This width is maintained to a point 51 nautical miles from the nav aid. If the airway extends beyond this point, the controlled airspace includes the areas on either side of the center line, which diverge from the nav aid at angles of 4.5 degrees. All mileage listed on Enroute charts are nautical miles, unless otherwise noted. The total mileage between compulsory reporting points and radio facilities is enclosed in a box. Mileage figures not enclosed in a box, such as 27 and 14, indicate the distance between reporting points, radio aids, and/or mileage breakdowns. In this example, the distance from Farmington to Dede intersection is 27 miles, and from Dede to Cape Girardeau, 14 miles. The total distance from Farmington to Cape Girardeau is 41 nautical miles. A mileage breakdown is identified by a small X and is normally associated with a course change where a reporting point has not been established. When flying between two nav aids, you normally change the frequency halfway between the two stations. For example, if you were flying from Tar River to Cofield, you would change to Cofield 23.5 miles from Tar River. In some areas, however, the actual point of change will be designated. In this case, the mileage from the corresponding nav aids is indicated with the changeover symbol. The facilities used to define a fix are indicated by arrows. In this example, Yummy intersection is defined by the 248-degree radial from Glade Spring VOR DME and the 295-degree radial from the Holston Mountain VORTAC. At locations other than where two airways intersect, a thinner arrow defines the fix. Here, Tripp's intersection is defined by the 041-degree radial of Falmouth and Victor 128. Where distance measuring equipment can be used to define a fix, an arrow with an open head is shown. with the mileage being determined by that listed along the airway. In this case, the DME distance to Calif intersection is 19 nautical miles. If there is more than one fix along the airway, the mileage to the fix from the nav aid is enclosed in a D-shaped box with the arrow attached. Here, the distance to trips is 30 nautical miles. Unless you are in radar contact, IFR position reports are required at certain points along the airway. These points are referred to as compulsory reporting points and are indicated by solid triangles. If the compulsory reporting point is at a navigation facility, the solid triangle will be a part of the facility symbol. Open triangles depict non-compulsory reporting points requiring a position report only when requested by ATC. On IFR flights, position reports are normally made by direct communications with the appropriate Enroute Traffic Control Center. The division between centers is designated by a patterned line. The names of the controlling centers appear on their respective sides of the dividing line. To provide direct communications throughout their area, ARTCCs operate remote radio sites. The location of each site is indicated by a blue patterned box containing the name of the controlling center, the remote site name, and the frequencies used for contacting the center when you're in that general area. Terminal airspace areas that require communications are indicated on NOS Enroute charts. For example, Class B and Class C airspace areas are depicted by blue shading around the primary airport. A solid border indicates Class B airspace. The white and blue cross-hatching surrounding Class B airspace areas depict the 30 nautical mile Mode C veil. If the blue shading is enclosed with a broken border, it is a Class C area. The border represents the general size and shape of the upper portions of the associated controlled airspace. Airports surrounded by Class D airspace will have a D inside a box after the name. Likewise, the primary airport of a Class C airspace area is depicted with a C. If the airspace is part-time, a star appears after the box. Information about the hours of operations can be found in the voice communication table, which is usually located on a chart panel near the legend. Areas in which fixed-wing special VFR flights are prohibited are indicated by the notation "No SVFR" above the airport name. As mentioned before, airports without an instrument approach are shown in brown, and airports with a published approach are depicted in either blue or green. With all airports, the airport elevation, availability of night lighting, and the length of the longest runway in hundreds of feet are noted on the chart. If an A appears with the name, ATIS information is available on the frequency shown. For terminal communications, such as tower, approach and departure control, and clearance delivery, you will need to refer to the air-to-ground voice communications panel. Non-directional beacons are low or medium frequency nav aids generally associated with instrument approaches. The location of an NDB is marked by a series of concentric brown dotted circles. Information pertaining to the facility name, frequency, and identifier are located near the symbol. An Instrument Landing System, or ILS, localizer course is depicted by feathered arrows when it performs an ATC function. The ILS frequency, identifier, and Morse code, along with the inbound course, are shown. Now, let's discuss the various altitudes shown on the chart. Minimum en route altitude, abbreviated MEA, is the lowest altitude between radio fixes, which meets obstacle clearance requirements and assures acceptable navigation reception. In addition, You can usually expect adequate communication at the MEA, although it is not guaranteed. This altitude is listed along the airway or route segment to which it applies. On some airways, the MEA is different, depending on the direction you're flying. For example, if you're flying west from Stano intersection, the MEA is 12,000 feet. However, if you're flying eastbound from Flood, the MEA is only 9,000 feet. A minimum obstruction clearance altitude, or MOCA, meets obstruction clearance requirements, but only guarantees reliable signal reception when you're within 22 nautical miles of the navigational facility. This altitude is listed when it is lower than the MEA. To avoid confusion, the MOCA is preceded by an asterisk. To indicate that a change in MEA or MOCA occurs on a route segment at other than a navigation facility, a break in the airway is shown, and small bars are placed across the airway center line. When the point is not a designated intersection or nav aid, the mileage breakdown symbol is used. Here, the MEA changes between the United States and Canada. At some intersections or fixes, terrain can interfere with the reception of the nav aid, which forms the fix. Where an altitude higher than the MEA is required to identify the fix, a minimum reception altitude, or MRA, is designated. A flag with an R is attached to the fix to indicate an MRA. The altitude is listed near the name of the intersection. In this case, you must be at 13,000 feet in order to identify window intersection. A minimum crossing altitude, abbreviated MCA, is designated whenever intervening obstacles prevent you from maintaining obstruction clearance during a climb to a higher MEA. The MCA is shown by an information grouping consisting of the Victor airway number, the crossing altitude, and the direction of flight. A flag with an X is placed at the fix where the MCA applies. In a few cases, maximum authorized altitudes, MAAs, are specified. These normally occur below special use airspace or because two VORs transmitting on the same frequency cause signal interference. They are indicated by the letters MAA, followed by the applicable altitude. Certain areas are designated special use airspace due to hazards or special activities that occur within them. Depending on the flight restrictions or activity, they are labeled as prohibited, restricted, warning, alert, or military operations areas. Each area has a designation number, and information on the restrictions can be found on the front panel of the chart. Military operations areas, which are depicted in brown, each have a designated name. Additional information about the area can be found on the front panel of the chart in a separate table. The isogonic lines, which are depicted in green, run through the entire chart. The amount of magnetic variation is depicted near the edges of the chart. Since all radio navigation radials and bearings are magnetic, this information is useful to you when you need to determine a true course. On Enroute charts, the location of an area chart is depicted by dashed lines. These charts provide blow-ups of certain major terminal areas, making it easier to read the navigational information. Area charts use the same symbology as Enroute charts.